Hello! In this video, we are going to prove the following theorem. Suppose f and g are non-empty families of sets. If f is a subset of g, then the intersection of g is a subset of the intersection of f. Now, if you recall, given a family of sets f, to say that x is an element of the intersection of f means that x is an element of every set in f. Okay, now let's get into proving the theorem. Now notice, we're trying to prove if this is true, then this is true. So let's suppose that this is true. From here, our goal is to show that everything in the intersection of g lies in the intersection of f. And to do that, give me an arbitrary element of the intersection of g. I'll call it x. Now remember, this means that x is an element of every set in G. Now we want to show that x is an element of the intersection of f, which means we want to show that x is an element of every set in f. In other words, we're trying to show that for all sets A in f, x is an element of A. So give me an arbitrary set in f. I'll call it A. Now since A is an element of f, and f is a subset of g, it follows that A is an element of g. Now, since x is an element of the intersection of g, we know that x is an element of every set in g. So in particular, x is an element of A. So putting this together, we see that under the assumption A is an element of f, it follows that x is an element of A. Since A was arbitrary, this means that for all sets A in f, x is an element of A. In other words, we have shown that x is an element of every set in f. And that proves that x is an element of the intersection of f. And now, we see that under the assumption x is an element of the intersection of g, it follows that x is an element of the intersection of f. And since x was arbitrary, this means that everything in the intersection of g lies in the intersection of f. So really, what we have shown here is, under the assumption that this is true, it follows that this is true. So we have proven, if this is true, then this is true. And that's exactly what we wanted to prove. So this completes the proof. And so yeah, that's pretty much it for this video.